5.7 is about the binomial theorem. So what you're doing is that you use what they call Pascal's triangle, and Pascal's triangle is really easy to build. If you start at the top and go down, you start with a 1, and then 1, 1, and then all you do is you add these two things to get this. So 1 plus 1 is 2. Always 1's on the outside. So then we have 1 plus 2 is 3, and 2 plus 1 is 3. That's where that comes. So that's how you build the triangle, to be able to use it to expand any binomial known to man. So when you do that, the squared one, that's why it's a squared plus ab times b squared. That's why that works out that way. So we're looking at a plus b to the 6th. I want to go to line 6. Okay, so how do I expand now? So I go to line 6 and I use that. So the first one is 1, and it's a to the 6th, b to the 0. Then what's the next number? Well, it's 6 is the next number, and then you just go down 1 on the a and up 1 on the b. And you continue that process through the whole thing. 15, a to the 4th, b squared, plus 20, a cubed, b cubed, and then 15, a squared, b to the 4th, and then 6, a, b to the 5th, and then the last number is 1, a to the, or a0, b to the 6th. Okay, and that would be your final expansion of it. Now clean it up, so you have a to the 6th plus 6, a to the 5th, b, plus 15, a to the 4th, b squared, plus 20, a cubed, b cubed, plus 15, a squared, b to the 4th, plus 6, a b to the 5th, plus b to the 6th. And that is your expansion of that. So you don't have to write 6 a plus b's and write them out. Now expanding this becomes fun, but you want to go to the 5th row. So you would build Pascal's triangle and go from there. I'm just going to give you the 5th row of Pascal's triangle. That's something that you'll have to build as we go. But 5, 10, 10, 5, 1. And again, we talked about building it, and I'll show you more about that in class. But this is what that row is. So again, as we're building this thing, you need to talk about the A and the B. Here's your A, this is your B. So again, we're going to start with 1 times 3x to the 5th. Then plus 5 times 3x to the 4th. And then negative 2 to the 1st. And then 10 times 3x to the 3rd times negative 2 squared, plus 10 times 3x squared times negative 2 cubed, plus 5, sorry, I don't mean to go down the next line, but it is what it is, 3x times negative 2 to the 4th, and then plus 1 times negative 2 to the 5th. So then I'm just going to simplify this stuff, so that's written out. Well, what's 3x to the 5th? 3x to the 5th, when I punch in my calculator, 3 to the 5th is 243. So 243, x to the 5th, plus now 3x to the 4th, again, punch in your calculator and come up with that number. So it's times 5 times negative 2 to the thing. So obviously the x to the 4th is going to stay there, and I just punch in my calculator 5 times 3 to the 4th times negative 2. And that's going to give me negative 810. So just make that a minus sign. Negative 810. Okay? Then what's next? We'll have x cubed, so I'm going to put the x cubed there, but I need the number. So it's just 10 times 3 cubed times negative 2 squared. So that's going to give me plus 1080 x cubed. Minus, and again, same thing here, 10 times 3 squared, now negative 2 to the 3. Okay, and that gives me negative 720. And that x squared stays there. Okay, the last one we have x here, so it's 5 times 3, which is 15, times negative 2 to the 4th. Gives me positive 240x. And then negative 2 to the 5th, again, just punch in your calculator, negative 32. And that is your binomial expansion. Fun things.